Introduce myself. My name is Rusmaniar from the Chemical Study program at the Faculty of Science and Technology of the Islamic State University of Raden Patah in Palembang. Fiber pressure is the pressure of fiber at equilibrium with its non-fiber phase. All solid and liquid have a tendency to evaporate into a form of gas, and all gas have a tendency to condense again. At a certain temperature, a certain substance has a partial pressure, which is the dynamic equilibrium point of the gas of the substance in its liquid or solid form. This point is the fiber pressure of the substance at that temperature. The formula is PA equal XB times P0A. PA equal fiber pressure is difficult to discard. XB equal mole fraction of solute. P0A equal pure fiber pressure. Fiber pressure that is difficult to dissolve will reduce the fiber pressure at the solvent, that is PA smaller P0A. The pressure for some substance increases non-linearly with temperature, based on the Clausius-Clapeyron relationship. The boiling point of atmospheric pressure, or known as normally boiling point, is the temperature at which the fiber pressure is equal to the atmosphere pressure of the environment. The formation of bubble increasingly requires higher pressure and temperature. This is due to the pressure of the liquid increasing with increasing depth. Consider the following illustration. In figure 1A and 1B, steam and liquid are in random motion when equilibrium is reached. Figure 1C. The number of fiber particles equal the number of vaporized particles. equal the number of condensed particles. Fiber pressure on a single component in a mixture affects the total pressure in a system called particle pressure. If there is a solute in a mixture, it will affect the Weber pressure because on the surface there are not only solvent but also solute. The more dissolvent substance, the smaller the Weber pressure will be. The following is a table that contains the chemical Weber pressure. The viscosity, or more precisely, the coefficient of viscosity of a liquid measures the resistance to flow under stress because the molecules of liquid are very close to one another. A liquid is much more viscous than a gas. The class spacing and the intermolecular force both contribute to this resistance to flow. Viscosity is discussed in somewhat greater. A molecule in the bulk of a liquid attracted by its neighbor about equally and over a long time interval does not experience an unbalanced force in any particular direction. A molecule in the surface layer of a liquid is attracted by its neighbor, but since it only has molecules on the surface are bound only to the molecule on one side. They do not have as low an energy as do those in the body of the liquid. To move a molecule from the body of the liquid to the surface requires the addition of energy, since the presence of another molecule in the surface increases to the surface area. It follows that energy must be supplied to increase the area of the liquid surface. The energy required to effect an increase of 1 m² is called the surface tension of the liquid. Surface tension is dealt with in more detail in the chapter on surface properties. For the moment, we supply note that the intermolecular forces are responsible for this phenomenon. Determination of solid structure using diffraction, X-ray, neutron, and electron. Defined by unit cell, symmetry, cell parameter, fill in unit cell coordinate of the atom. How to describe the structure? Ball and stick. Polyhedra fill of space. Structure liquid. Liquid display fluid properties. The liquid can flow. Imagine the shape of the container, and if placed in a closed container, will distribute the pressure evenly to edge, surface, and the container. If liquid is placed in a bag, it can be pressed into any form. Unlike gas, liquids are almost incompressible. It has a nearly constant volume in a wide pressure range. It does not expand to fill the empty space in a container, but forms its own surface and is not always costly mixed with other liquid. These properties make liquid suitable for hydraulic application. Gas is one of the four basic forms of material. The other is solid, liquid, and plasma. Pure gas can be composed of atoms, such as noble gas, such as neon. Element molecule composed of one type of atom. For example, oxygen, or compound molecule composed of various kinds of atoms. For example, carbon dioxide. The gas mixture will contain a variety of pure gas, such as air. What distinguishes gas from liquid and solid is the separation of very large gas particles. This separation usually makes the colorless gas invisible to human observation. The interaction of gas particles in the presence of an electric and gravitation field can be ignored as shown by the constant velocity vector in the figure. One type of gas that is commonly known is Tiedemann. Solids have a certain shape and volume. The distance between the particles in the solid is very tight. The particles in a solid cannot move freely. Liquid substances have a certain volume, but don't have fixed shape. Liquid form depend on the media or constant used. The distance between particles in the liquid is more tenuous. Particles in liquid can move freely, but their motion is limited. The gas substance has no specific volume and shape. The distance between the particles in the gas substance is very tenuous. Particles in the gas substance can move very freely.